Kia ora, year 12 and 13. This is question 1, part D and E from the 2016 complex number part paper. So question D is a merit question where you're given W equals 1 plus 2i. Then you need to manipulate it as follows. So you've got to find the value of this thing here and end up with an answer of A plus BI, and you've got to show all of your working. So I think the easiest way to do this is to start separately by working out what's the conjugate. Don't try and put it all into here first. Don't do that. So the conjugate of W is 1 minus 2i, and now we're going to work out also separately W squared. So W squared is this, which works out to be 1 plus 4i, plus 4i squared, which is 1 minus 4 plus 4i. So as usual, we're just grouping the real part and we're grouping the imaginary part. So that's the W squared bit done. Now let's do the W over W conjugate bit. So W over W conjugate, just change pen, will be 1 plus 2i over 1 minus 2i. We need to multiply numerator and denominator by the conjugate so that we rationalize it. Right, so here in the denominator we get 1 minus 4i squared. Doing this very slowly. Many of you will be groaning. So in the numerator we get 1 plus 4i squared. So that works out to be 1 minus negative 4. So 1 plus 4 and 1 minus 4 plus 4i. So I can hear some of you laughing at how slowly I'm going. I'm doing that on purpose because you really don't want to chuck easy marks away when you understand how to do it with small errors. Okay, so now we've got the two bits. We've got W over W conjugate, this bit here, and we've got W squared here. Looking back to the question, we need to figure out W squared plus that. So we just add the two bits together now. Oops, wrong pen. So W squared plus W over W conjugate is equal to negative 3 plus 4i minus 3/5 plus 4/5 i. Now we need to clean that up. So it's going to be negative 3 and 3/5 plus 4 and 4/5 i. That's one way to write it, but I would rather write that as negative 18/5 plus 24/5 of I. Okay, so that's that one done, and that's a merit tick. Okay, on to the second question, which is more interesting, and this is a locus problem. We're told that the locus described here is a straight line, and we have to find the gradient of that line. So there are two ways to approach this problem. The first way, which if you've done A-level you'll be most familiar with, is to look at that and straight away identify that we are looking for a perpendicular bisector. I'm going to go through that first. If you're doing level 3 and you're finding loci problems quite hard, you're probably going to want to use an algebraic method and substitute in z equals x plus iy. So this is the method for loci questions that always works, right? If we just say, let's let z be some general complex number and then figure out what values it has to satisfy. But looking at this, a nicer way to do it is to say, well, what is this left-hand side? Well, we've got z minus 2 plus 3i. We can write that as z minus 2 minus 3i. Now we can interpret this as the distance between some complex number z and this point here, which is 2 minus 3i. And we can draw that, and we're going to do that in a minute. On the right-hand side, we've got z minus 1. So we can think of this as z minus 1 plus 0i. So this is now the distance from some complex number z and the point 1 plus 0i. And we're looking for the set of points where those two distances, so this one here, this distance, and this distance, are equal. Okay, so what we've got is we've got the distance between those 2 points. So we've got z minus 2 minus 3i. Right, so we can plot that here. Here's 2 minus 3i. And we've got z take away 1 plus 0i. So that's sitting here, right? What we want to do now is we're going to find all of the points for which those two distances are the same. Now, if we look at the line segment we've got there, let's just join that up as best we can. You can see that the gradient of that line is going to be found by doing this. We've got the first point is, you can think of as 0, 1, and the second point is 2, negative 3. So m is equal to rise over run, so down 3 and out 1. That means that we know that the perpendicular bisector here is going to be all of these points on this line. And all we were asked to find was the gradient of that. So the gradient of the perpendicular bisector will be negative 1 over negative 3, which is 1/3. Okay, so the answer to the question is that the gradient's equal to 1/3. And you'd need to write down and explain that it was a perpendicular bisector, right? So you've got to show a little bit more working than I'm doing here, because for most of you, you're going to do this using some algebra. So that's what I'm going to go through slowly now. But it really, really helps to have that picture in your head first. So let's now do it by substituting in the point. So we've got x plus yi minus 2 plus 3i is equal to x plus yi minus 1. We're going to group up the real and imaginary bits. So we'll get x minus 2 plus I times y plus 3. And that equals x minus 1 plus I times y. Right, the modulus is just the distance of the point from the origin. So we can do this, just applying that definition. Square both sides, expand, and simplify. Whoops, we missed a square there. Right, I'm doing each step of this, partly because often loci problems are show that problems. So you want to make sure that you don't skip any steps of working. So there's y squared plus 6y plus 9. Right, and it's worth just checking back that we haven't mucked anything up, but that all looks okay. Now look what's going to happen. The x squareds on each side are going to simplify out, and so are the y squareds. So that leaves me with negative 4x plus 6y plus 13 equals negative 2x plus 1. My goal is to get to a gradient, so I'm going to make y the subject of the equation. 6y is equal to 2x minus 12. So y is equal to 2/6x, going very slowly, minus 2. So y is equal to 1/3 x minus 2. So the gradient is 1/3. Right, and we're done. Okay, so that was the first excellence question in the 2016 paper. Thanks for watching.